Hello, so we are back, and this time we have a nice classic Dell laptop to repair. So check here. It's a Dell i5 Gen. Now the history of this laptop is most important. This is part of a job lot from the guy which is buying. I have a customer which is buying faulty laptops from eBay. So let's plug a charger on this one and see what it's doing. Now plugging a charger and the laptop, check there. Plugging the charger and we don't have the light on the charger. What is interesting is when you have, let's say this current is taken by the battery. Usually the current doesn't go straight up, so it will take like few seconds in order to see the current there. And also you can see a pre-charge current first. But this one, soon as I plug the charger, the current is going up, which means this is dead current. That's how it's called. Most likely it's current taken by a short circuit. So let's open the laptop and have a look inside. Dell Latitude 3400. No battery, no RAM memory. Yeah, that's not a surprise. When you buy things from eBay, probably they try to sell the laptop but still make some money from like hard drive, RAM memory, battery. Yeah. Okay, let's plug the charger. Plug in the charger, and it's doing exactly the same thing. Let me grab the thermal camera because something must get hot. Can you spot anything? Yeah, probably the hard drive was here and it's not anymore. We can plug in RAM memory to test it. That's fine. So we have the thermal camera, and check here. But that's a it's not a MOSFET, it's burn board. Lol, and it's proper hot. Check here. Here is the problem. Well, this was quite simple. So I believe we don't have shorted MOS. I believe we have shorted capacitor. Just because it's getting hot means the short is not 0 ohms. Or is the MOSFET? Okay, let's check the voltage there. Yeah, the voltage is important. Because we don't have a short, we have a current consumption of 440 milliamps. Yeah. So the voltage is 0. Lol. So how is taking 400 milliamps? So actually it is short. So the 400 milliamps is taken by who? Probably the first MOSFET. And it's on the other side of the board. Okay, that's fine. Okay. I will unplug the charger. So I unplug the charger. Let's check for short. Because here we have a short, clearly. Yeah, check on the screen, 2 ohms. So you see, this is an interesting case. I mean, it is short, but all the current is taking is 400 milliamps, and the voltage is still there, 19 volts. So which one is shorted? I'm assuming this one, right? Okay, it's not anymore. And this one is shorted. So actually both are shorted. I mean, it's not even point because the solder is cut anyway. Check there. You can see the track. The track is burned. Wait. We have a shorted layer there. Yeah. Lol. So it's a shorted layer or the MOSFET is shorted? So what do we have here? Huh. Let me plug the chart. Let me come with some alcohol, yeah? some alcohol, and I will plug the charger. The charger is plugged in. So place your bet. What do you think? Is the MOSFET or the board layer? What do you think is the problem? Because you can see the MOSFET is getting hot also. So what is your bet? Well, something made me believe actually we have burn layers here. That's what I believe. Huh? It's not burn. Check here. It's healthy board here. It's not burn. You know what? Let's remove the MOSFET, this one, and test after that. 480 degrees. Okay, so the MOSFET is removed. This is an all-in-one thingy. You have the MOSFET and the driver inside. That's what you have. Now let's check for sure now. It's not on focus. Yeah, it is now. So checking for short. It's still short. It's still short. You see? You see? You think this capacitor is shorted? This capacitor is shorted also. But can be because of the board layers. Here we have a hole on the board. Check here. It's like a proper hole till the other side. Now this is a hole. You can see it's going on the other side of the board. I think we should turn around the motherboard. But the board is looking good. So check here. Here you have a little bit of it's carbonized, but otherwise check here. It's healthy board. Like healthy board. You know what I think I will do? I will check with the thermal cam. Let me clean it. You can see, so you can see the healthy board there. So it's not like, you know, the all layers are burned apart from this hole. So here indeed you have a hole till the other side of the motherboard. Let me plug the charger. I mean, yeah, indeed, this looks like that kind of job which is coming from eBay. Untested laptop, right? Probably does a description. Yeah, you can see the whole area there is hot. Wow. Proper hot. Let me limit the current. 1 second. I will limit the current to localize the fault better. You know what? This capacitor is getting hot. No, still there. Let's turn around the board, yeah? Look, even this MOSFET is getting hot. Okay, let's get on the other side of the motherboard, because I believe there is more damage. And that hole which is going through the motherboard, it's a concern. Yeah, it's Monday today. Here it's a bit windy, some storm outside. But yeah, we are starting the week with easy jobs like this one. Yeah, not much headache. All we have to do is to clean the burn layers, and yeah, it's fixed. You know how annoying it is. You try to take the board out, but the motherboard is behind of the hinge. So basically you have to leave the hinge in order to take the motherboard out. So you see, this is what I called a decent power input circuit. Because we've seen on the past, yeah? Shorted MOSFET, shorted capacitor. You plug the charger short. And it's like, okay, but what the both MOSFETs from the input are doing, you know, why they're not cutting down the power? You see, this is the case. This is how it's supposed to work, yeah? You plug the charger, you have 400 milliamps, you still have 19 volts, it's not short on the charger, but the motherboard is shorted. So the input circuit is doing what it's supposed to do. Because you have to protect the laptop, and then you have to protect the charger, because you have a shorted motherboard. So I'm happy finally, and I swear, I think this is the first laptop I'm seeing something like that. You have the main power rail shorted, but when you plug the charger, 19 volts, 400 milliamps. This is the first laptop which actually that input circuit is working how it's supposed to work. Let me unplug the lol. Check there. Yeah, kind of expected, you know. Expected. Yeah, check there. So what do we have here? So here we have probably, yeah, you know what? Probably everything started from here. I mean, whatever are those, but I believe are capacitor, right? Are not inductors. Those are gone. Yeah. But removing them, do you think we don't have short anymore? That's the question. So here we have a healthy track, you can see. Proper healthy. Here is fine. Let's clean it. And it's looking good. I mean, for me, you know, I have no problem with this board looking like that. No issues. It's fine. Everything is fine here. Okay, the motherboard is dry. Let's check on the other side. Here. Let's check if we still have short. No short. Ah? Wait. It is short, 7 ohms. We still have short. Why we have 7 ohms? You know, my concern is still that hole. You know which hole? This one from here, which is going from one side to the other side. Yeah, this hole. Yeah, this one, which is coming here. Yeah, here. We have still burn board here. No. You know what is pissing me off on a job? When the capacitor is removed, but it's not removed by me. Check here. So you see here, it was probably a capacitor, which I didn't remove it. So someone else removed this one. Or the capacitor just fell down. So you understand what's going on here? Here you have ground. This is ground. And you see those round pins are plus. So those round pins are not supposed to touch the ground. That's the idea. Okay, so here is looking fine. We can clearly see the plus tubes or holes, or you know how you want to call them. Here is burn. Here. Yeah. I found it. Here you can see. So there indeed is burn board. Here inside. Yeah, here deep inside, indeed, here is burn board. Yeah. Yeah, here is no healthy board. You can see. So this one is burn here. But if it's burn, we can remove the ground track. Yeah, we don't need it. So this is the ground track, and we can remove it. Why we have such a big ground track? You know, big grounds are good. Not only like low resistance on the power track, but also for cooling. Yeah, cooling. Yeah, here is ground. But the board is still looking good. So check here, you can see here is healthy board. Let's brush it. Perfect, check there. It's not that healthy board because you can see the fiberglass. You can see here the layers of fiberglass. Yeah. So this is plus, this is plus, plus. Perfect, let's check for short now. Let's see if we still have short. So from ground here, is not short anymore. You can see. Check here. So here you have the ground. You can see the ground probe, and here you have the plus, and it's all good, all fine, no short. Here is short because it's ground. You can see short, but here is not short. Here is short because it's ground. Here is not short. Here is not short. 11 ohms, and here 0 ohms. Wait. Why here you have 10 ohms on this pin? But it's not our problem, right? 11 ohms. No, that's not our problem. No, this is something else. This is different fault. That's a good question. Why on this capacitor we have 10 ohms? Because the plus is here, and here is fine. It's not short. Yeah, we don't care about that. Let's check a different. Yeah, which pin it is? Number 3, right? No, this one. Yeah, it's fine. Check that. Check on the screen. So another chip has 10 ohms on this pin. So that means 10 ohms on this pin is fine. We are good. We are good. We can clean it now. We can solder back the MOSFET. We can rebuild the plus track, and yeah, all good. Perfect. Yeah, all good. You can see the solder is kind of not present on those pins here. You can see it. Yeah, let's apply some solder. Let's apply some rosin. Rosin is good. Yeah, rosin flux. We have rosin everywhere, which is good. Solder, that's fine. Let's come with 180 degree solder here. Just to lower the temperature a little bit. Perfect. And here we have one pad missing, but that's fine because that pad is not used. Oh, all those three tracks pins are for the plus. Good. Let's solder the chip back. This one. Yeah, let's solder. It has to be like that. We have a lot of ROS in there. Perfect. What do you think? Yeah, it's not perfect yet. Let me grab that solder ball. Good. Now let's reheat one more time this chip. Because when you push the chip, the solder was coming out from here. And it is possible, you know, to have bridges behind of the chip. Yeah, now it's fine. Yeah, perfect. We don't have to press the chip. If we are not pressing the chip, we know everything is fine. Okay, what is left now? What is left is to test if the plus is still good, if the plus track is still good. So the plus track should be from here to here. It is. Check that. Check on the screen, yeah? Plus track is here. We ground. We ground is 2 ohms. Lol, I can't believe. Now it's short again. 2.5 ohms. Do you think the MOSFET is shorted? Do you think? Check the 3 ohms. No, it's because it's hot, right? Yeah, must be. Must be because it's hot. Let's cool down the MOSFET. Don't tell me actually the initial fault was a shorted MOSFET. Yeah, we cool down the MOSFET. Let's check for short. It's still short. I mean, we have a dead CPU actually here. We have a dead CPU. I didn't even check the resistance to see the resistance. Let's remove the MOSFET again. So we remove the MOSFET. Let's check for short. It's not short. The MOSFET is shorted. You know how we can check? Very simple. 1 second. So we have the MOSFET, and the plus is here, right? Yeah, this one. So here is plus, here is ground. It's not short. This is ground. No, this is the output. No, the output is here. 2 ohms on the CPU. This one is fine. This one is ground. So if this one is ground, means I should have a short from here to here, and I don't. Check here. Why I don't have short from here to here? If this MOSFET is shorted. Why? Why is not short here? Huh. Okay, this is kind of weird. Possible our MOSFET to be good. Okay, so here is plus. We have this, we have this. Good. Let me remove this extra solder from here. Good, it's looking good. Let's solder the chip back because I'm not convinced about this MOSFET is shorted or not. So what I'm gonna do, like usual, heat up the MOSFET, dip the MOSFET into the rosin, and now let's solder that MOSFET. Perfect. Perfect. Now I'm not gonna take that solder out. That's the plus, right? Yeah. Let's check with ground. So checking with ground, short. That's plus. Let me cool down the motherboard. Because a hot MOSFET is a shorted MOSFET, so let's cool down first before we are checking again. Let's see. Yeah, we still have short. Now, why we have short? I don't understand, because I test the chip, right? We tested together. Oh lol, it's short between the coil and the plus. It's not short with ground. It's not short with ground. I can't believe. You see, that's how you can easily get tricked. So basically, our short is from plus from here to the coil there. Let's check. So from here to here is not short. This is ground. And this is the coil. Check on the screen. You can see 0 ohms. So inside of this thingy, the short is between the plus and the coil. Actually, which is the high side MOSFET. So what is short is the high side MOSFET. Yeah, feels bad, man. Yeah. I was thinking short to ground, but it's not. And now it's not short. No, it's not short. Okay, that's fine. That's okay. Let's test it. Let's see what it's doing. What it's doing. We still have 2 more coils there, right? Yeah. Let me grab the laptop. Let's see what it's doing. It's working. It's worth to order another MOSFET. That's the question. Should work with 2 MOSFETs? Yes, should work with 2 MOSFETs. If the driver is not checking actually the phase, yeah, because you can have if it, on our complex laptops, they have only one feedback line for all 3 power supplies. And you will ask yourself, okay, sorry, but how? You have 3 coils together, right? They are soldered together, 3 coils. You have one feedback line. What kind of feedback? I mean, if 2 are dead and 1 is working and you have 1 volt there, that means all 3 are working. You know, how the chip, the driver, knows only 1 is working and 2 are not working. It's checking the phase. Yeah, each power supply has different phase. So it's not like the switching, it's not like all 3 power supply on the same time. No, first you have, it's like pistons on the car. You have first, second, third, yeah? It's same like on the car with pistons. They are switching only 1 at a time. Okay, so the charger is plugged in. What is this is the screen? No, it's not the screen. It is the screen. I mean, kind of unexpected. Usually, the screen connector is near to the CPU or GPU. Yeah, okay, let's plug the charger. Let's plug a RAM memory. RAM memory is plugged. Plug in the charger, and I heard, yeah, I raised the current 80 milliamps, but I heard a spark. I swear I heard a spark. 70 milliamps. 60 milliamps. Okay, let's check the power button. The power button is here, so we need this connector. I swear I heard a spark. Pressing the power button, nothing happened. Lol. Yeah, probably that CPU. Let's check the main power rail. So the main power rail voltage is, check on the screen, 12.5, you can see. 12.5 volts, so the main power rail is present. So probably this is the coil creating the main power rail. Yeah, and the output of the, yeah, 19 here is the input. And the output must be here, 12.5. Feels bad, man. But you know what? I'm curious, what is taking 60 milliamps? Let's see. What is taking 60 milliamps? Lol, what is that? Where? Here? Here? On the other side of the board? Here? Huh. What is there? What is there? What did I miss? There is a bunch of chips. I mean, I can't see anything. No, exactly there is here. Okay, let me plug the charging port again. So plug in the charger and check there. What is that? No. I don't know, some thingies. Some fingers are getting hot. Let's see. This one, which I don't know what it is. This thingy, which is doing what? Let's check the voltage there. So this, we have 5 volts. What this is doing? 5.2 volts. 19 volts here. Who knows what is doing? The AC chip has voltage. I mean, the main power LED is present. This is a MEC chip. And here we have 0 volts. Here we have 0 volts. So basically we have no voltage on the AC chip, right? Yeah. Nothing. Okay, it's dead. Because the 3.3 volts power supply is not working, and most likely is here. Do you think the AC chip is shorted? Let's check. So here is fine. Here is fine. I can't see short here. Here, It's fine, it's not short. Here is not short. Okay. Here is not short. So the AC chip is not shorted. I think it's not shorted. You know what? I think I will stop moving forward from a simple reason. Yeah, the MOSFET high side MOSFET from this hybrid chip was shorted. That means the CPU got 19 volts, 12 volts, sorry, 12. And the CPU has 2.4 ohms, 2.4, and my multimeter has 0.6. So the CPU has under 2 ohms, 1 point something ohms. So even if I'm, even if I'm moving forward and spending more time, I can end up with, with a laptop which I can't fix it because it can be a faulty CPU. Now, what I'm getting for those job lots, yeah, is like £40 for a motherboard repair. I can't really spend a lot of time on those laptops. So those should be like, easy repairs, cheap repairs, cheap and easy repairs. That's what those jobs should be. And I cannot get involved too much because obviously no one it'll gonna pay for the repair. Well, at least we know we found this thing is shorted. I'm surprised on this motherboard actually are more faults. And I don't understand why. Why there are more faults. I mean, the fault was kind of clear. That MOSFET got shorted, and yet then the board layers got burned. I got that. But why we have more problems here on this board? This is something which I don't understand. So one more time, plug in the charger, and it's taking nothing. Oh wait, the charger was not plugged. It's taking 60 milliamps by that chip which is getting hot. But the main power LED is present. We don't have 3.3 on the EC chip for some reason. But we do have on the main power LED 12.5. Yeah, so we fixed what we could fix it. But getting like further to find out why the 3.3 is missing, it's it's no work for this particular repair. So I'm gonna stop here. Hopefully you enjoyed this video. It's just a short one. A non-repair. It's always something to learn from non-repairs, You've seen how I got it wrong with the MOSFET. I have to desolder the MOSFET twice to find out actually it's shorted between the plus and the output. Crazy. I think I'm getting older. Okay, so I'll stop here. See you on the next one. Bye.